Calculators handy. We are doing more with formulas, which are always fun and easy. We are talking about compound interest today. We're going to be able to set up and evaluate real-life applications using the compound interest formula. A common application of exponential growth is compound interest. Compound interest is interest paid on both the initial investment, called the principal, and on previously earned interest. And we can compound that interest like your bank. You might have a savings account. Every time you get a statement, each month they compound the interest. So they total it all up. And so you'd compound that monthly or compound semi-annually. And so we can compound it more than just once a year. The formula is the amount that you have is equal to P times the quantity, 1 plus R over N to the NT. 1 plus R over N to the N times T power. A represents your total amount, meaning the total that you have in the bank after a certain period of time. P is the principal. Yeah, not principal. Principal. It's your friend. The difference between principals and principal. Your principal, who's your pal. Okay. Have you heard of that? You don't get it? There's principal, and then there's principal, P-L-E. Your principles are like what your beliefs. Yeah, no, this is principal. Yep. The principal is the initial or starting amount. It's the amount you start with in your bank. R is the rate. Again, as a decimal, always. And that is the annual rate. And then N is the number of times we are compounding. Number of times compounded per year. C-O-M-P-O-U-N-D-E-D, per year. The number of times you compound it per year. So, for instance, if you were compounding monthly, how many times per year would that be? 12 times per year. If you were compounding semi-annually, what does semi-annually?
Some years.
It's half a year. So how many times per year would that be? Every 6 months. How many times per year? 2 times per year, semi-annually, yeah. Weekly? $52. Daily. 365. Okay. Generally accepted. Okay. And T is time. Okay. So Dave invests $300 in an account with a 5% interest rate. If he makes no other deposits or withdrawals, find his account balance after 15 years. If the interest is compounded with the following frequencies. All right, so he has $300. So what is 300 in our formula here? The principal. The principal is 300. That's the amount he's starting with. And then what is our 5% interest rate? Yeah, that's the R, 0.05. Good. And we know it's time is 15 years. And if it's semi-annually, that would be what information? N. N equals It's semi-annually, how many times per year? 2. Yeah, 2. All right, so the formula would be A equals 300 times 1 plus 0.05 over 2 raised to the 2 times 15. And I personally just like plugging it all in one. All right, we got calculators. This is always done on a calculator. So as long as you use parentheses, you will be good. So I have 300 times the quantity 1 plus 0.05 divided by 2. And then raised to the 2 times 15. And so you can see you can get it all in on one nice big long line. Super easy. And we are talking about money. So $629.27. So that's compounded twice a year. If we compound it monthly, what is our end value? 12 times per year, yep. And so our formula for this one, we're starting with $300, 1 plus 0.05 over the 12 times per year, raised to the 12 times 15 years. And again, 300 times 1 plus 0.05 over 12.
And you could always copy down.
Yeah, you could. Yeah. All right, to the 12 times 15. And we get $634.11. Is it better to compound semi-annually or monthly?
Well,
Monthly. The more often you compound, the more precise that you're going to make more money. Yeah. So that's always the fastest. All right. Number 2. If $2,500, what is that? P, principal, $2,500 is deposited into a savings account earning 8% annual interest. What is that number? So 8%. 0.08, that's our R, 0.08. And then we have earning 8% annual interest. How much will be in the account at the end of 25 years? That would be our T is 25 years. If it's compounded quarterly, what would our N be for quarterly? 4 times per year, yep. So we have our principal, 2,500 times 1 plus 0.08 over N of 4 to the 4 times 25. 2,500 times 1 plus 0.08 over 4 to the 4 times 25. Ooh. How much money? $18,111.62. Great. That's pretty good. I mean, when you think about it, you put in $2,500, and 25 years later, you haven't added or done anything with it. You're just sitting in an account, and it's now at $18,000. That's not bad. That's free money, right? Okay. It's pretty good. So we did that. We opened our 529. Do you guys know what a 529 account is? Yeah, college savings account. At 3 days after the market hit rock bottom in 2009. So, well, that's when the market actually hit rock bottom. We were in recession, but it tanked. And so we opened up our 529 then with $1,000 and didn't add anything to it for like a decade. But at the end of that, it already had about $9,000 in it after like 8 years. It was pretty good. I was like, cool. That's pretty good. All right. Let's see. What do you, go ahead and do daily. In would be what? 365. Will you go ahead and take a second and figure that out? Did you do it already? What'd you get?
I got 18,468 and 59.
58 or 59? Okay. Again, we compound more often, we're going to make more money. Yeah? Okay. Amelia turned 6. Her grandparents opened a college savings account for her with an initial deposit of $500. The account earns 3.2% interest compounded bi-monthly. Our rate would be what? And bi-monthly, what does bi-monthly mean? Every 2 months. So we have to be careful. Twice a month would be semi-monthly. Semi meaning half, at the halfway point of each month. So semi-monthly, you would have it twice a month, but bi-monthly is every 2 months. So compounded bi-monthly would be n equals 6. So every 2 months, okay? If our grandparents make no other deposits, how much money will be in the account when Amelia can access it at age 18? She did her answer key wrong. All right. T is 18. All right, so we have 1 plus 0.032 over n, which is 6. To the n times 18. 6 times 18. Yeah, she did her.
Wait, but she's not. They put it in when she was 16.
Oh, turn 6. You're right. This should be 10.
No. 12.
Oh, 12. Thank you. Yeah, that 12 would be better. That's better math. Thank you. All right.
Theoretically.
All right. 500 times 1 plus 0.032 over 6 to the 6 times 12. I'm getting... What did I do wrong here? Oh, I forgot the decimal point. That makes a really bad answer. Didn't say that. There we go. That's better. All right, we get $733.32. All right. Interesting. Okay. I'm feeling okay about this. Are you guys feeling okay about this?
Yeah.
What about number 5 here? We've got 2 3/8%. How do you? What are you going to do to deal with that?
Put in your calculator.
How do you do that?
Put in 3/8.
Alpha. Oh, I like what you said. Put in 3/8, and then add 2. There we go. Hey, hey. And then I heard alpha F1. Is there one for that?
Yeah, down one more. Just 2.
Just number 2? Oh, and then what would you do? Oh, 2. See, I didn't even know. And you could do that. Okay.
But that gives you.
But then that's still a fraction. So I like the 3/8 and then add the 2 wholes to it. So that's pretty good. All right. So that would be R would be 0.02375 on that one, just in case you're curious. All right. So we also have continuously compounding interest, which is kind of nice. So we can compound monthly, daily. We could compound every minute. We could compound every second. Or we can just say, hey, let's do this continuously compounding. And again, it's the same as yesterday. The formula is A equals P E to the RT. Same thing. We're compounding continuously. It's a natural progression every single moment. Then we can use the PERT formula. So on number 6, $800 is invested in the account at 6% interest rate, compounded continuously. And that word there, continuously, tells me I want to use the PERT model. If no other withdrawals or deposits are made, find the balance after 20 years. So I have $800 times E to the 0.06 times 20 years. Very easy there. Yep, $2,656.09. No, it's really not. Let's do number 8, and then we'll be done. Number 8. Carla is investing $1,500 in a new 30-year retirement account. Determine which of these interest rates and compounding periods shown at the left would be her best investment option. So for option A, we have 5.5 interest compounded monthly. So let's see, what would our R be for option A? 0.055. And what is our N? How many? 12 in times per year, so 12 times per year. All right. Let's see, that is compounded monthly. I've got to use the Plunert formula. Equals, let's see, A equals P, the 1,500, times 1 plus R over N to the NT, 30 years. So make sure you're using the right formula. And then option B is 2.7% interest. That's a lot less interest, right? Compounded continuously. Let's see. So that R is going to be 0.027, but compounded continuously uses the E formula. So that's going to use the PERT model. So 1,500 times E to the 0.027 times 30 years. And then I can do all my calculator work. 1,500 times 1 plus 0.055 over 12 to the 12 times 30. All right. $7,781.08. And then 1,500 E to the 0.027 times, whoops, a daisy 30. $3371.86.
So 5.5 is way better.
Yeah, 5.5 interest compounded monthly is way better than compounding half as much continuously. Interesting. It's a big difference. What if they were the same rate?
Oh, then the continuous.
Then the continuously one, yeah? Okay. Because this one is compounded continuously, we use the PERT model, yeah? And the one compounded monthly or compounded daily, we use the long formula, the R over N to the NT formula. All right, that's pretty easy, yeah? Yeah? All right, you guys have a worksheet. So pay attention to the words.